All right, good evening. I'm Ron Payne, and I gave this briefing almost 5 years ago to the day, but I've added to it a little bit and taken away a little bit, updated it a little bit. So this is pretty much steered toward our new members who have never done coax cable, have never put on a connector, things like that. Little introduction. I've been a ham since 1962. I'm from Livermore, California. Been an amateur extra since '74 when you had to go to the FCC and you had to take the 20 words a minute code test. I was a radioman in the submarine service. I rode the USS Halibut and the USS Plunger. And when I got out of the Navy in 1970, I joined the Foreign Service. And my first tour was Thailand. I was unable to get a license, could not get a license, no matter what I tried. Went to the Philippines, I got a license. Hammed in the Philippines, one of the first 5 Americans on. In 1978, I went to Beirut, Lebanon during the war. I was able to get licensed. It took 6 months. From there, I went to New Delhi, India for 4 years. I was able to get licensed there. And of a country of 1.3 billion people, there was only 2 CW operators in the whole country, and I was one of them. Life was good. I did a de-expedition to Kathmandu, Nepal in 1982. That is written up in the May 1983 QST. I went to Frankfurt, Germany for 3 years, got a license, never got on the air one time. London, England, never got on the air one time. Gaborone, Botswana was a de-expedition that I did in 1988 for 1 month out in the Kalahari Desert. Mogadishu, Somalia, during Black Hawk Down. I was on the air during Black Hawk Down, which was October 1st and October 2nd, 1993, if anybody was there. Special event stations, etc. So ham radio is a big part of my life. It always has been. Guys, today I'm going to talk about coax cable and connectors. It is the most popular transmission line, at least after World War II. Coax stands for concentric axis, concentric axis. It has a shield which helps prevent the pickup of external energy. You can place coax cable right up against metal. Great for ships, aircraft, tanks. Mr. Lloyd Espenscheid and Herman Affel of AT&T invented coax cable back in 1929 for use with television. Imagine, we were looking already at television in 1929. The first cable that you could actually buy was called RG8 that is, RG8, Radio Guide. That was 1946, War Surplus. RG8. RG stands for Radio Guide. And the U that you see behind that is usually utility, meaning I can buy RG8 in Germany, I can buy RG8 in Japan, and the same here. And oh, by the way, guys, I do recommend Belden, Times Microwave, and Wireman. Don't shortchange yourself on coax. Spend some money. Get the good stuff. It's obviously very important to connect your radio to your antenna. Don't buy some of this cheap stuff that's out there, and there's a lot of it out there, believe me. Cross section, if you take a knife and cut the coax, you have a jacket that's could be either PVC, polyethylene, or polytetrafluoroethylene, which is Teflon. I like the Class 2A, which is a PVC jacket, non-contaminating, meaning the sun isn't going to cause a chemical reaction with the jacket and the braid. Petroleum resistant. Everywhere I was overseas, we would lay the cable right on the roof in tar, especially Africa. Just put it right into the tar. It'd be no problem at all. Direct bury. UV resistant is very important. And the companies like to tell you that the Coax has a lifespan of about 10 to 15 years. Yeah, don't believe it. The outer conductor can either be braided, solid, single, or double shielded. The dielectric can be polyethylene foam, polyethylene solid. The stuff we use for maritime or going into space, we use Teflon, and I have Teflon here, or we have air dielectric. And the interconductor can be solid or stranded. And just to let you know, the RF currents do not travel inside the wire. That's called the skin effect. The skin effect where your RF travels on the outside of the interconductor and the inside of the braid, okay? Just like a waveguide. All cable has loss. Sorry, but it does. It has loss. Please remember that as your frequency goes up, your attenuation goes up. Attenuation decreases as thickness and quality. Notice I said quality. Power handling capability. If you want to run big watts, you're going to need big cable. When I was in Thailand, we had a base station that ran 50,000 watts, and the coax cable was 4 inches in diameter. Foam or air is preferred, but they're very susceptible to moisture. You got to make sure you keep the moisture out. Always use, this is very important, guys, especially VHF, UHF. If you only need 45 feet from your radio to your antenna, then don't buy a 100-foot roll and coil up all of it behind your desk, because that coil of 55 feet is called attenuation. Coax cable can dry out. It has a shelf life. When I worked for Raytheon, we went over to the warehouse one day, found some cable that was 25 years old. The dielectric had turned brown. The shield had turned green, and we threw it all away. It does have a shelf life. If you're going to store it in your basement or your shed out back, cap those ends. Cap them with plastic. Keep the moisture out. We live in Virginia. Let's see, sun, rain, snow, ice, wind, acid rain. We have all of that here, everything. I want you to replace your coax at home when you can go outside and do this, and you get a handful of black jacket on your hand. That means that your cable is starting to be UV'd. I want you to also check your cable like this and look for cracks and punctures. We got squirrels, we got chipmunks, chewed, nicked, flattened. How about this, flattened? How about somebody drives a car over your cable, or you get up on the roof and somebody walks on your cable on a hot day? This is what I do. Every year, just before winter, I disconnect my cable up at the antenna and I put a dummy load on and I check the attenuation. So far, so good. It says here that I have replaced my cable every 7 to 10 years, and I'm overdue. Only because I am 77 and I don't want to go up in the attic where the insulation is this deep. You know what I mean, right? And my antenna's working just fine. Okay. Treat your cable right. When we go to field day, unroll your cable like this. Unroll it. Don't take a roll of cable and pull it off like this, giving you every single turn is what we call a kink. And when you wind up your cable, do the same thing. Hand over hand over hand, making a nice loop that you can use later. Try not to drag your cable, especially the connector, through the wet grass. I just love this. I teach an HF class, and the students like to go out to Bull Run Park, and first thing in the morning, they'll roll that cable out through the grass, hook it up to the radio, and the Viswar is like 10 to 1. Connectors are full of water. So keep your connectors out of wet grass. And of course, don't drag your cable through rough pavement. Not cool. Bend radius. I get that all the time. It's the diameter of the cable, like this is 0.405 inches, times 10. So that's about 4 inches. Okay? That's your bend radius. Always preserve the proper thickness of your dielectric. In other words, don't flatten it. Don't step on it. Treat it with real respect. The most important thing is the continuity and that distance between the center conductor and the braid. That's the most important to maintain that 50 ohm impedance. Okay. Anybody use RG174? Oh, all right, yeah. And 316 is the mil spec version. Yep, very good. The only difference is this is Teflon. This is tinned. That's tinned. Good cable. I do have all these up front here. I'm not going to pass them around, but if you want to come up later, I have what they look like. So RG174, if you wanted to buy that, it's called Belden 8216. Okay, that's just the Belden number. Every company has its own number for the coax. So this is for very, very short interconnect cables, okay? It's very high attenuation if you try to use it for too long a length. I keep it under 10 feet for VHF, UHF. Okay, the next cable, RG58. This is kind of the one I grew up with, RG58. Great stuff. Let's see, RG58, there we go. Notice RG58C. I get this question all the time. I'm going to go buy some RG58. Which one do I buy? Well, RG58 standard, just plain RG58, has a contaminating jacket, so it's not spec. It's not something you'd want to put outside. RG58A is also a contaminating jacket. B, you can't even find it anymore. So guys, if you're going to buy RG58, I want you to buy RG58C, tin copper, 19 strand, non-contaminating PVC. This is the best. And I ran this to my antennas for years and years, from the 60s and 70s, the Philippines, everywhere. I ran RG58. And then guess what came along? RG8X. Anybody using RG8X in here? Oh, Kevin, are you using the real RG8X or the good stuff? Good for you. Okay. RG8X has just taken over radio. When I was at Raytheon, this is all we were buying for wiring inside the offices. LMR 240 UF. Does everybody know the company LMR? That's Times Microwave. LMR stands for Land Mobile Radio. 240 stands for 0.24 inches in diameter. So it's a little bigger than RG58, and it's a little smaller than RG8. Make sure that you specify UF, ultra flex. You want the one that's flexible. And to me, this is an outstanding cable. I think 99% of you that have come over to my house for interconnect cables have requested LMR 240 UF. Any questions, guys? Great for satellite, yeah. Double shielded, guys. Double shielded. Mike.
Contaminating and non-contaminating.
Contaminating and non-contaminating jacket. What's that mean? It means that the jacket material will not form a chemical reaction and turn the shield brown or green. Okay? Contaminate. It'll contaminate due to sunlight. Don't get that mixed up with UV resistant, but non-contaminating. One thing I like about Times Microwave, they got a born-on date on the cable. It tells you exactly what day that cable was made. Look at this. April 16th, 2021. How about that? It's kind of cool. So I'm real impressed with Times Microwave. They make a nice cable. All right. RG213. Is anybody still using this? I know Lee's got some. Kevin, you got some too, huh? This is the old RG8 cable that became mil spec. I buy SIW, which is superior insulated wire. I buy this from the RF Connection. But notice the shield. It's not tinned. Center conductor is not tinned. But it's good old, reliable cable. Been around forever. So if you still have some of this, all the connectors that I have at home, they'll fit it. But let's go one better. Let's go one better, and I'm going to show you the Ferrari of cables now, according to me. And this is Belden 9913F7. This is the greatest cable I think that's come along in years. Double shielded. It is the same diameter as RG8, the same diameter as RG213. And now the good part. The braid is tinned. Strands, 7. This first braid is tin foil, which gives you 100% shield. Not 96, not 93, not 88, 100% shield. So, I also buy this at the RF Connection. Please keep in mind, this doesn't have an RG number. It's an RG8 type cable, meaning that it's 0.405 inches in diameter. Now, you didn't think that other manufacturers were going to let Belden have all the fun. So again, our friends there in Times Microwave came out with their own brand called LMR 400. It's the same stuff. Either one, you bring them over to the house, I can put a connector on for you in about 90 seconds, okay? Now, one thing I want to make sure, if you're going to buy this, make sure you buy F7, Flexible 7. If you buy just 9913, guess what? It's going to have a solid center conductor. It's going to be hard as a rock. Same way as Times Microwave LMR 400. If you don't buy the UF, the Ultraflex, it's going to have a solid center conductor, and it's going to be hard as a rock, and the air dielectric. Get the flexible. Okay? All right, let's move on to connectors. What we would like a connector to do is appear to the RF that it's not even there. Just a straight cable into the radio. Would it be nice if you could solder a cable into the radio? Never have to bother. That wouldn't work. You want your connectors to make good mechanical and electrical connections hundreds and thousands of times. I put easy in parens. Easy to assemble. If any of you in here, and I know I see a lot of gray hair, you've put on the solder connectors, that ain't easy. That can take 20 minutes. You got to make sure your connector possesses the high frequency characteristics that you need. It has to have good pressure. In other words, when you connect it up, it's got to fit tight. Nice and tight, okay? If it doesn't fit tight, by the way, you can get electrons jumping back and forth between the center pin and the other socket, causing noise, and we call that PIM, passive intermod, and that's good on transmit and receive. Okay, threaded, bayonet, and push-on, and if you're going to order a connector, I know we call these type N. We call these type N, right? But if you order them, some companies like the company I work for, you would say, I need some UG75s, not a type N. Most important part of the RF system is your connectors. Got to put them on right. And guys, I'm going to say it right now. This is 2024, and we crimp, 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 and crimp some more unless you have to solder. I refuse to put on solder connectors anymore. I have all the crimp tools. Crimping is the way to do it. The good part is that when you crimp, you haven't heated with a great big iron. You haven't heated the dielectric and caused it to melt. And now you have a connector with a huge impedance bump of God knows what. Amphenol, Times Microwave, Pasternak, there's some great connectors out there. I buy everything from the RF Connection in Gaithersburg, Maryland. I have for probably 40 years. Okay, PL259. We've all put these on. Invented in the 1930s by Edward Quackenbush. for, guess what? RG8 cable, which was invented in 1937. PL stands for plug, and it mates with the SO239. SO stands for socket. Originally designed for the 0.405-inch cable, which we call RG8. You can also get reducers. And the dielectrics were World War II. We had Rexolite, phenolic. Today, most every single connector that I have on the table here, the dielectric is Teflon. And it's kind of funny that the solder connector is still $1.50. And back when I was a kid in 1962, I would go to Oakland Airport surplus and buy them for $1.50. They stayed. It's really a junk connector, but we all use it because it's cheap. All your radios, you buy a $10,000 radio, you got PLs. Non-consistent impedance, vulnerable to moisture, you better wrap it. If it's outside, you better wrap it up. And if you want to solder one of these, you know, I'm going to pass this around. This is a solder. I'll pass that around. I did that last week. I used to be good at this, and I have really lost my touch. I've been spoiled by crimping. Greatest connector ever invented, the Type N. Mr. Paul Nile at Bell Laboratories in 1943 invented the N connector for use with radar. N for Nile. How about that? 50 ohms, good up to 18 gigs. The insertion loss, the connector basically isn't there at all. It's got a little gasket inside. It's pretty waterproof. I still wrap them outside. It's great for VHF, UHF. And the only disadvantage, they're expensive. They're about 12 bucks a piece. I just did this for the NVFMA, and that's a $26 connector there, Type N, on LMR 600. BNC, anybody use these? BNC, hey, good deal. It's one of my favorites. Now, this is really funny. I dug up all the names that I've heard over the years from engineers and classmates. Berkeley Nucleonics Corporation, bayonet nut coupling, barrel nut connector, baby N, British Naval, British National, bayonet. They're all wrong, guys. That's all wrong, man. Paul Nile invented the N connector, right? Carl Conselman invented the C connector. This is right around 1948, 49. And he worked in Hazeltine with Octavio Salati, and they came up with the BNC, which is the bayonet Nile Conselman connector. Now, that's the true story. So if anybody ever asks you what BNC stands for, that's it. All right? Everybody got that? They also have a TNC, nice small size, low power handling capability. And then I had somebody actually tell me that the slots radiate at 4 gigs, like I care. So, I do want to pass this around. I have a Type N male, and I have a BNC female, okay? If you're ever in a jam, fits perfect. Oh, no kidding. Very good. I have actually had to do that in the field. I wouldn't leave it out in the rain, but you made the connection and, gee, you just didn't bring your adapter kit, did you? Okay, now the one taking over the world. By the way, the BNC, up until a few years ago, was the most popular connector on the face of the earth, and the SMA, which we call the Sure Mighty Awful, is now taking over. You guys see this? Infrequently. So what do we do on our little bow fangs? On, off, on, off, on, off. And every time you take your antenna on and off, you're wearing that center pin down. There's an SMA and an SMB and an SMC, SMD, and I'm not sure of an SME. But I got to hand it to them. Frequency-wise, it's a killer. Very popular for this, and very popular for satellite use. I've put on hundreds for Mark Kanawati there and his satellite company. These are for the satellite, and we're using a lot of SMAs these days. These are 14-karat gold flashed connectors, not plated, flashed. It's about 25 molecules thick. And these go into space. Disadvantage, excessive interconnect cycles over tightening, and that's why just before we launch, we go through every single SMA in the satellite, and the last one I did for had 160 of my connectors on board, and they torqued them to, let's beam that in, 8 inch-pounds, guys. Don't tighten them any more than that, 8 inch-pounds. And you might need one of these, they're only $140. Okay. Little nomenclature for you guys that are going to be at Mike Imany's garage tomorrow morning. We have what we call the plug body of the connector. The back, where the braid goes over, is called the barb. The ferrule then goes over that, and we crimp. We have male pins. Does any connectors have female pins? Sure, female connectors. Duh, yeah. Everybody asks me, what's that little hole in the connector? In the pin, what's the hole for? Everybody thinks it's a solder hole. Well, you can solder through it. I do all the time, but it's called the inspection hole to make sure that your center conductor is up at a sufficient length before you either 1, solder or 2, crimp. With the PL259, we have the subassembly. We have holes to solder, 4, not 2, 4. We have the cup, which we like to cap. The one I passed around has a nice cap on it. And then the one we always forget. I'll bet everybody in here, John, I know you have, I have, everybody in here that's put on a PL259 has done a beautiful job, and you forgot to put the coupling ring on. I'd like to have a dime for every time that's happened. By the way, guys, one other thing, that's knurling. This is knurling, which tells you one thing on connectors. Hand tight. Don't you go putting a wrench or pliers on that. I've had students take a wrench, Loctite, torque it down, and when it slips, then all these little pieces come out, and then the next poor guy that goes over to take the connector off gets a handful of filings. Knurling means hand tight. Okay, adapters. I want everybody to know that an adapter is an expedient interface. We wouldn't think of keeping them outside. We wouldn't think of, at least I wouldn't, keeping them inside. I try to put the right connector on, okay? They have very poor waterproof characteristics. They have non-constant impedance, very good point of failure. Adapters should be avoided at all possible times for permanent installations. Please remember that, especially outdoors. Now, adapter kits, I have one here. You can literally put anything on anything. Here you go, JC. Matter of fact, JC, it's the same one that's in the picture. Go ahead back. There we go. These are about $100. Great to have in the lab. I mean, I don't think I couldn't teach a class without an adapter kit. One of my students one time says, "Hey, this is pretty great. I'll bet you could put a type N on a garden hose." So I thought about it, and I went home and did it. This is a type N male to a garden hose. Right, there you go. You can come up and see that. I hope nobody in here has done this. Stacked adapters. Look at this guy, wants to put two cables together. He puts a N barrel. There. The worst I ever saw was overseas. I was on an embassy roof and right after a hurricane, and I was pulling the cable, and I came upon seven adapters floating in the salt water on the roof of an embassy. And needless to say, the water had trickled all the way, gone up about 10 feet each side.
You want to get the best adapter kit?
Yeah. Yeah, there you go. That's true. So, guys, when it comes to adapters, try to put the right thing on in the first place.
Are all 7 of those between
Two cables. Yes. Now, Don, here's another thing. What if they were all the same family? What if all 7 of those were type N's? That'd be okay. Yeah, you would a bit, but if you're going to stack connectors, if you're going to stack adapters, try to keep it in the same family and you'll be okay. All right, guys, now, my first love, crimp. Why do we crimp? It gives you a solid connection. We call it a cold weld, okay? It's also, not just mechanically, it's a great electrical connection. You're actually making that connector part of that braid. You didn't meld any dielectric. All braid is connected. Not just a few strands, like when you solder the PL259, you've soldered 4 holes. When I crimp this on, every single piece of braid is crimped. Very high reliability, and we have no solder fatigue here. Okay? Ease of installation. You guys come over and I'll give you a demo on how easy it is to put these on. Yes, sir.
Metals have oxides, so
Yeah.
and typically the oxides are very good insulators. You know, a few atomic layers. Or
Okay.
when you crimp, what happens to the oxide? How is it that you get a good conductive connection with no intervening insulators?
It turns out that one of the little secrets is silver oxide is actually a better conductor than copper.
It's a good conductor.
It's actually a very good conductor. Now, there's aluminum on the oxide. That's a problem. Copper oxide is a problem. But that's not what you're dealing with. He's dealing with silver. And if it's silver on silver or tin on tin, it doesn't oxidize.
Thank you.
Some of the tin oxides, of course, are also conductive. I don't know how good a conductor they are, and it depends upon the composition.
Okay, guys, the bottom line is robust, uniform, and consistent. Okay? These are not cheap. TE connectivity, the body of the crimp tool is about $125, but each set of dies now is $250. But the reason, these are mil spec. I use these when I build connectors to go into space. The inside is chrome. They're chrome layered. You want a little cheaper? Times microwave. Excellent. Okay? Right around $100. And then I even have a crimp tool for my old Type F connectors that we use on TV and satellite TV. Okay? But I have a complete set at home. And you too can also have a nice crimp tool. This is the one, oh, I have the picture up here. Never mind. The RF connection in Gaithersburg sells these. 125 each, unless you're a VWS member. In 5 or more, we can get them for 110. Guys, you don't need $400 worth of crimp tools. Your hams. This is just perfect. I put on a whole bunch of connectors last week with this. It works like $1 million, and the price is right. And it has every die that you'll ever need for ham radio. All right, now, here's some that I've crimped, and I took a picture of. This is a BNC female on RG316. BNC male, Type N male, SO239, and guys, what are all these missing? Shrink wrap. Guys, I want you to remember, if you put on a connector and you don't shrink it, it's the same as mowing your lawn and not edging. You're not done. You always shrink wrap. Keeps the dirt out, a little bit of moisture out, gives you a little, makes you a little stronger cable. And what else? It looks nice. Okay? And of course, then you need a heat gun, don't you? I'm going to forfeit the installation up here because we're too spread out. You couldn't see anything. And we've run over quite a bit. So look, guys, don't be cheap. Don, you'll like this. Less dB costs more dBs. Does everybody like that? I mean, you guys go out and you spend $3-4K for a radio, and then you go buy crap coax with cheap connectors. It's part of the system, and it's the most important part of the system is the connectors and the cable. All right? I have some more on YouTube here. So that's all I have. Questions, please.
What do you recommend we use for wrapping the connectors for an outside installation?
Funny you mentioned that, Gene, because I took that off of the weatherproofing. Can you give me one more slide? Thank you. Gene, I took this off, and then you asked. Good. I like this company called Coax Wrap. This is self-amalgamating silicon. Now, this is white. I use black. But here's the thing. When I was a kid, you only had one thing available to you. You had Scotch 33, and you wrap it, and then the following summer, it's all sticky and messy and gooey and yucky. This stuff, you put it on, You take a razor blade at the end of the year and it comes off just like a banana peel. I recommend Coax wrap self-amalgamating silicone tape, and that's what I use at home. That's what I used in all those embassies in Africa and Asia and everywhere else. Good stuff. Any other questions? Yo.
How do you recognize a 75 ohm from a 50 ohm,
Ah.
like BNC or something like that?
Okay. All I have to do is pick up, let's see, here we go. All I have to do is pick up a type N or a BNC, and I will notice two things. The pin will be bigger and the spacing will be larger in here. Okay, and I'll know, oh, 75. Gee, do you think any hams would ever accidentally put on 75 ohm BNCs or 75 ohm type Ns? Think that happens? Yeah, happens all the time. And you might not even notice it. Okay. Anybody else? It's what?
It's also written on the jacket.
Yeah, it's written on the jacket. That's right, 75 ohm. Yes. Matter of fact, for your information, RG59, not 58, RG59 is 75 ohms. It has the same thickness as LMR 240, 0.24 inches. So it's very easy to grab a BNC out of the drawer, 75 ohms, and put it on and go, oh, true story. For you guys tomorrow, if we have to solder and you smell chicken, then you're holding the iron wrong. Do you think anybody else? Okay. And don't think I haven't had students do that in my class.